Okay, hello and welcome to the week 4 CREO tutorial. This week we will be covering the design of helical gears, which is very similar to the design of spur gears with one slight difference in how you draw the teeth. The equations are slightly different, as I'm sure you'll remember from the book, but other than that it's more or less the same process. So let's get started. First thing is you want a new model, make a new part, and we're going to start off same way as before on the XY plane, please. Just to make it easy, do a sketch. We want a circle, some diameter, doesn't matter what it is because we're going to change it later. Next, we're going to extrude that. Again, just leave it. It doesn't matter what dimensions it is as of yet. Now we're going to add our parameters. And here are some I prepared earlier. So we have the number of teeth, the normal module, the pitch diameter, normal pressure, helix angle, and width. So, same as previously, just put them in. Number of teeth is going to be an integer of value 32. Normal module. Would be a real number because we don't need it to be an integer. Value 2.8. Pitch diameter 100. Normal pressure of 20. What else we got? Helix angle 26. And a width of 25. Well, that's what you get for typing too fast. Width of 25. Okay, hit OK, and now we want to add the gear equations. So these will be posted up alongside the week's material. I'm sure you'll recognize these from the book. I've just written them out to be a little bit neater. I have made a mistake there, double space, okay. So, all you do, same as with a spur gear, we're going to drop those into the relations window, verify. If you've copied it over correctly, it'll all work. Hit OK, and now we can get back to actually making things the right size. So this first one, the first diameter that we're going to add is the root diameter. So link that relation, hit OK. Now that looks too thick. So we're going to make the extrusion thickness equal to the width. Okay, and there we go. Now we're going to sketch the other three circles. Again, as long as the centers are concentric, it doesn't really matter what width they are, because we have a base diameter. Link that. We have a pitch diameter, and this very last one is the outer diameter. And yes, I know I'm spelling that incorrectly, but you'll note in the relations window, I also spelt it improperly. Hence, because it requires you to call it by the same name to link the variables, I have to also spell it improperly here. it honestly doesn't matter what you call it as long as you can recognize it for your own purposes and can remember what it is. I could call those ring 1, ring 2, ring 3 and link them in exactly the same way. The name itself is immaterial. As long as you can link them by the same name, then you're fine. Okay. So that's the first three. Next thing is we want to add a datum. We want a curve from equation. Now our reference is going to be the center set of axes here, the XYZ axis. So you just click on that. When it goes orange, it'll turn this nice light green, which means you got it. Then we're going to add the equation. Pretty much the same equation as last week. Verify. Yes. Now, because I fixed that base diameter, let's also fix it here. Let's try that again. Yes. So you see that because I had the incorrect name here before, I was calling a variable that didn't exist, and it was that single character difference in the name, that added underscore, that makes all the difference between an improper name and a proper name. Okay, that is verified. Here we have the involute. That is good. Okay, next thing we're going to do is make the tooth thickness. So we're going to sketch on this origin face. Go to sketch mode to make it easy, and then do an arc with center and ends. So first click is the center of the arc. Oh, sorry, before that, because it won't snap this intersection terribly easily, we're going to make it easier by adding some references. So we're going to add the involute and the pitch diameter and solve. And now you see when we try this, first click is the center, second click is the first end of the arc, and it's going to snap nicely to the intersection. So reference just tells it that it's an important curve, and effectively makes it easier to select the curve or important items on the curve, such as intersections, midpoints, that sort of thing. Okay, then we're going to click on dimension, and because this is a straight line dimension, which is pretty useless, we're going to change it. We're going to change it to an arc length, because that can be linked to the tooth thickness. So first click is one end of the arc, second click is the center of your axis, third click is the other end of the arc, then middle click, so using the center button on the mouse, somewhere out here. And here's your new dimension. You see it's now in terms of an arc length. And we're going to link this to transverse tooth thickness. Yes, I just can't spell today. Okay. There you go, linked. Now, selecting that line, we're going to add a datum point. The offset reference is going to be the end of the curve, and the offset is going to be 0.5, which just means it's going to be halfway along the curve. That's all good, nice and simple. And now you're going to make a datum plane, selecting the datum point and the central axis, which is a datum axis. And there you go. Now we've got the center of tooth plane, I suppose you could call that. Then we just want to quickly mirror the involute curve about that. Okay, now this is where it starts to get a bit different from the spur gear. So what we're going to do now is we're going to do a helical sweep. And first thing we're going to do is we're going to tell CREO that we don't want to extrude an object here, we just want to extrude a surface. So we're going to click on this button, sweep as a surface, and now we proceed as per a regular helical sweep. So the profile, we are going to define along the center of tooth plane. And now it's partially placed, so we're going to select the axis in the middle, and it's going to be fully placed. And okay. Sketch mode, that's what I'm looking for. That'll make it easy. Then you're going to take a line. You're going to go from one side, one face of the gear across to the other face. Hit escape to accept it, and then go OK, and done. Now, see how the pink arrow is here? That is where we want it for now. But if, because of the way you selected the planes, it's come up on the other side looking like this. Simple enough fix, just click on it and it'll go to the other end. And what this is telling you is which end CREO is going to start the sketch from. Which, not the sketch, rather the sweep. And this is important because if I start it at this end, coming out of here, then, and I use this tooth as the model for the sweep, as the sketch for the sweep, then it will start here and come winding out around pretty much as you'd expect. But if I had it this way, it's going to start with the face on this end and then go out this way, which you can change pretty much just by changing the hand of your sweep, but it's not what we want. It just makes things more complicated, and we don't need that because this is already a very finicky process. So next we're going to select the helix axis. It's going to be the center axis of the gear. We're going to give it a pitch equal to lead, which is one of the variables we defined in the gear equations. Okay. And now we need to actually sketch this thing. So what I want you to do is, because we're sketching a surface, we're not going to define it like a normal closed sketch where you have to have a geometric shape with no lines sticking out and no breaks in it. Quite simply, you're going to take one line from the center of the gear, this center line axis, and go out along to the datum point. Hit escape, hit OK, and there we go. Now, it doesn't look like much because that's just a plane. It's a single line that's been extruded. But what that does give us is it gives us the trajectory for our next sweep. So now I want you to go sweep, references, and I want you to click on the very end of this little plane we've just created. Okay, and now where it says section plane control, I want you to give it a constant normal direction, and then select this large horizontal plane that coincides with the lower face of the gear here. And then we're going to do our sketch. So same as for a regular gear tooth, we're going to go project, get the two involute curves to the outer edge of the gear, and we're going to take the inner, so the root diameter of the gear. And now notice that it doesn't, in the circle I've selected doesn't entirely coincide with the what's being rendered for the root diameter. That's because CREO renders things as very low poly files, so it approximates circles with a low number of faces wherever it can, simply to save on processing resources, so you don't max out your graphics card. It looks a bit weird, but you can tell that it is part of this circle because it is periodically intersecting with it. So this circle is the actual shape that CREO has stored in its memory. This polygon is just the rendered shape that you can see. Anyway, so now we're going to close this off. So you're going to take a line across, and we're going to close it on the other side as well. Okay, and now we're going to delete the excess segments. So click, hold, drag if you want to just drag through all the lines. It makes it nice and quick and easy sometimes. Left click, by the way. Okay, now we have a closed gear tooth. Hit OK, and here it is. A little bit broken though, you'll notice, and this is something we came across in class as well. It's really simple to fix though if it looks like your tooth is kind of levitating out like this. Basically all you do is you go references, and where it says horizontal vertical control, we're going to change that from automatic to normal to surface. And that's because CREO for some reason just likes to hold the shape at a constant rotation when it projects it. Given that you're spiraling around a circle, that means you're going to change the angle of the tooth relative to the gear, which we don't want. So if we tell it to go normal to surface, it just hugs the surface of the gear, and done. There's your tooth. Okay. Now we're going to go pattern. We're going to take that and we're going to throw it around the whole gear. Going to pattern it about the center axis. We have number of teeth. Okay, doesn't like that. Whatever. It's 32. 32 teeth. Time for a calculator. So we have 360 degrees. We're going to divide that by 32 teeth. 11.25 degrees. There we go. It's going to regenerate, and there we go. There is your spur gear. Very nice. So now, just quickly, because in a couple of weeks' time we're going to look at assemblies and animating gears, I'm going to get you to do a quick bore in this gear. So usually, of course, you have a gear mounted on a shaft, on a bearing, or something to allow it to rotate. We're not going to cover bearings over the course of this because I'm going to just show you how to download pre-made ones from SKF, because designing a bearing from the ground up is a bit tricky, a bit beyond the scope of this course. It requires a lot more complicated mathematics, and you're taught to just select them based off of the requirements that you can calculate. So the way I'm going to teach it to you is that once you've calculated which one you need, you can go to the website, grab it, download it, and then just import it into your assembly. Okay, so before we finish this up then, we're just going to go sketch, sketch view. It's just good practice. I'm going to make a circle, and I want you to make that of diameter 40. Go OK, extrude, and we're just going to cut out of there. Okay, well, that is unfortunate. Okay, so part of this plane is still in here. So let's see if we can't modify this without wrecking the gear. So we're going to edit the definition for the helical sweep, and going to edit the sketch, and we're going to move this okay. So that has, because we've deleted something that it was referenced by later, and this is the limitation of parametric software, because we've deleted an object that was later referenced by another object, we then need to provide it with a new object of reference. So what we've got to do is suite 1 needs to be redefined with this new reference. So yeah, so the surface is exactly the same as it was before. You've just got to relink it. And now one regeneration has failed, and that was the sketch. That's sees it as unresolved. Okay. Sometimes in CREO it is simpler to just redo these things manually, and that does happen. So now that we've re-established the link, everything's regenerating normally. We're going to go sketch, circle, diameter of 40, and extrude, and there we go. Now we've got the bore, and that plane is gone. Now save this by some name, because you're going to need it in 2 weeks' time. Thanks for watching.